Everyone, check this title as the ML and computer vision interview from the data to deployment. This is not just a call name; it's a promise. By end of this time, you will not only get the main ideas, but also know how to talk about them in a way that really stands out. So we are going to cover everything in machine learning and computer vision, from the first bit of data to your model working life. So this series is your secret tool to nail these interviews and also feel some super confident. And let me just tell you about a bit about my own journey in the computer vision and also in machine learning. So I have been through several interviews myself, and honestly, I was rejected from most of them early on. I really wish I had such, let's see, videos, but that experience taught me a lot. So I have also had the chance to be on the interview committee, and I found myself asking the same tough questions I once got. So what is more, I have had also the privilege of helping many people landing their dream jobs in this also field. So I'm here to share what I have learned from both sides of the tables to make sure that you don't make, let's say, the same mistake I have done. So as you can see here, think of it like building a house. So you need a strong base. This slide fundamentals every interview test. Is that the base? We will start with the data. Why keeping your data clean and separate is the key to avoid big problems later. And we will also clear up the difference between loss and metrics. And understand also that what your problem learned from it's not always what truly show succeed successfully, let's see. And we will look at making predictions reliable, so your model don't just guess but give a solid answers. So get this right and you will show interviews you will know the core rules of machine learning. And regarding the data, so data is the engine, or let's say the heart of any machine learning algorithm. So interviews, let's see, know it. So this slide is a question, data question they love, let's see, to ask. So shows where your real world skills shine. So we will talk, let's say, about smart data splits, going beyond simple ways to define the data. So you avoid hidden problems and get fair results. We will dive into the handling of missing data and balanced data, how to deal with imbalanced data, because in the industrial, let's say, real project, you will face many scenarios that most of the data unbalanced. So this will give you a smart way to clean and balance your data set to top model performance. And we will unlock the power of data boost, showing how to make your data bigger and your model, let's say, tough. This part will help you talk about real data problems and solution with confidence. So modeling a deep dive. So now let's just get the exciting part. This is the exciting part. This is not just about knowing models' name. It's about using them wisely. We will explore the transfer learning, how to use powerful pre-made model, or let's see, pre-trained models to solve the new problems super fast. And we will make training tricky easy and I mean easy to understand, covering key ideas like stopping early, pick the right patch size, and also smart learning creates for stable, strong models. And we will compare different optimizers and also combining several models, helping you, let's say, to choose the best tool to build a solid and accurate model. So this part will make you a much better model, let's say, builder. And for the computer vision, I just try to, because this is my major is a computer vision engineer, so I have to make some stuff from regarding the computer vision stuff. So for those who are love, let's see, images and working with the videos, this is for you. Is your best to call talk. So we will break down the convolution, showing how models see and understand the pictures. So also I have several playlists on the computer vision machine learning. I will put it in the description. And also then we will compare to big names in object detection, YOLO and faster RCNN, and we will look at the performance and also accuracy, helping you to pick the right one for different real-world uses. Sometimes faster RCNN is better than YOLO and vice versa. We will see with these scenarios, and we will look. We will finally, let's see, cover the key industry tricks like making models smaller for phones and maybe for the edge devices like Korea, or there are several key edge devices that I have been also working with several edge devices, and I might also after maybe this I will try to start with this how to make, let's say, deep learning algorithm runnable in edge devices like as I said maybe Korea 260. I have been working with this intensively, and I will try. Let's see, we'll cover this industrial tricks and like making model smaller for use phones and edge devices. And this section will give you an edge in any talk about the computer vision and how to optimize, let's see, algorithm algorithms for this uh, for such cases. And finally, not finally, but MLOP questions that it's also sometimes assume that you already familiar with machine learning or computer vision. Now we'd like to build a system, real life system on in the production. So we have to move, we have to go through MLOps. I also have a course in this. It's a playlist in the YouTube. I will put also the description in this. So this is where you, let's see, really show your experience. So building a model is one thing. Getting let's say you have to build a model, but getting to work and stay working in real world, it's another, let's see, issue. We will show how to serve your model using strong tools like fast API, Docker, and maybe Kubernetes, and also explaining why they are great for smooth, big scale development. And we will then cover automated test. Maybe not, let's see, dively into the coding, because this already somehow covered in another playlist. But I will just show you how to do stuff correctly. And we will also cover the automated test and also monitoring, including way how to track your model versions and roll out new ones without risk. And we will talk about watching, protecting your model, make sure that they run well and stay, let's say, safe. Mastering on MLOps, you will prove you are ready to I mean for ML machine learning engineering positions. And as I said in the beginning, this also covered in some in a playlist. I will put the link in the description. For this slide here, the evaluation matrix. Some guys, let's say some guys, they know how to run the algorithms, how to calculate the accuracy, and but sometimes they don't know which matrices to use, which matrices to use. Sorry. So your model ready, but how do you know, or let's say show it's good or not? So sometimes the accuracy it's not a good option at all. So we will see these scenarios, and we will help you to pick the best way to measure your model for your specific task. So looking let's see simple accuracy to understand how well it performs and meet the business goal. We will focus on a solid proof that showing you how to use the confidence level and proper A/B tests to get reliable results. And we will explore, let's say, smart cost evaluation, and where you think about the real impact of different errors, making your check truly useful. And this part will help you confidently show and explain your model values. And real-time system design. So in today's fast world, speed is everything. And this slide, real-time system design, gets you ready to build a system that work fast under the pressure. So we will share speed tricks to make your model super quick, from making them smaller and I mean to run them in efficiently in a different devices, let's say edge device, CPU, GPU, edge device, and etc. We will help you to choose between running models on device or in the cloud. Sometimes you would like to run the inference time in the cloud, or it's better to run it in the edge devices. We will see the advantage and also the disadvantage, and we will give you a way to handle a big traffic jumps, making sure that your system stay quick and steady even when busy. And this section we will help you to design a strong, fast ML systems. And some of these also, I mean, most of these stuff is already discussed in the previous playlists, but I will try to make it here as a concrete topic, so you can just go through this, and hopefully you will prove that you need. I mean, let's see, you are expert in this field and nail the the job for the troubleshooting. So finally, we'll get to the troubleshooting, because in the real world things will go wrong. Sometimes you have built your model and it's perfectly running in your stuff, even in the production. But at a certain point, you will get some issues. So this has happened. Let's see. This is let's say a daily base of trouble of the issues. So and we will and knowing how to fix them in a super valuable way, and we will look at the common problem like sudden accuracy drops, dealing with sometimes you have strange NAND, let's see, non values, and sometimes you will have so what I face, for instance, we send some images through the MQTT, and sometimes you get the images are corrupted, and this we will see how to handle such issue. And this whole series from data to development, your interview, I will see a toolkit, and I hope I had this before, is made to give you a full start to finish understanding of machine learning. It's about seeing the whole picture from raw data to working watch and maintain the system. This is, let's say, I will say, your best preparation. And wait a minute, please. Yeah, as you can see here, great ML candidate don't just code. They understand the data design and also deployment. This is the main point of our series. It's about taking your skills beyond just writing a code. It's about becoming complete machine learning professional who can handle every part of the project, of any project. I will see. It's accumulated experience. but I will try to give you my 9 years experience. And this series will give you the knowledge, the confidence, and also making smart thinking to not just answer interview questions, but to truly embrace. So you are, let's say, ready to become that a great ML candidate. So if you like this video, please subscribe to my channel, like the videos, and if you have, of course, any question, just drop it down in the comment below. I will definitely answer it. So see you in the next video. If you have imbalanced data set under the curve and receive operating characteristic, let's see, AUC-ROC, this is your friend for imbalancing dataset. So imagine you have a model and you would like to know how good is it to separating positive from the negative classes. So this is work also for binary classification. So this is exactly what AUC-ROC tells us. So, and also, what about the score? The score, it's ranging from zero point 0.5, which is like a flipping a coin. It's randomly if it's zero point 0.5, and and if it's, let's say, one and, or let's say close to one and one, which is perfect discrimination. So the higher value, it's a better. It's a better performance. Let's say. So the AUC-ROC doesn't care about the threshold. It's a threshold independent, which means it evaluates your model across all possible, let's say, decision boundaries. As you can see in this graph here, it will try to calculate the ROC. I mean the performance under the several thresholds. And it's all about ranking. How will your model rank, let's say, positive higher than negatives, rather than just counting correct predictions. So and compared to the accuracy, so don't try to use accuracy if you have imbalanced data set, because imbalance will accuracy will give you, let's see, not a correct result. It will it's a way less sensitive to class imbalance. And imagine you have a data set with thousand of okay images and 10 of not okay images. And if the not okay images were classified as okay, so the percent will be 90%, which is super high. But it's correct. All the other classes, all the other class values, let's say prediction, are false. But we also have the good accuracy, but this is not applicable. So don't use accuracy for the imbalance data set. And yes, and it's also, as you can see, it showed you the trade-off between true positive rate and false positive rate. And I think that's it for today. And also I uploaded for let's see, a video on this with with a simple numerical example. You will understand it, of course. Thanks for watching, and see you next time. One of the most underrated choices in training neural network is the batch size. It might look like a small details, but it has a huge impact on training speed, generalization, and convergence quality. So let's break it down. So a small batch, they update the model more frequently, but with noisier gradient. So if you have, let's say, stochastic gradient descent, which is updating the weight with every sample. And this noise can actually be a good thing. Let's say, it's like adding a regularization effect and then leads to better generalization. And the downside is the training per epoch is slow, because every epoch will try to forward, and the back propagation will do it for the same batch. And the next one is large batch. So they produce a smoother, more stable gradient with fewer updates. This makes faster training per epoch, and better, let's say, hardware or resources utilization. But there's a catch. They sometimes fall in a sharper minima, leading to a generalization gap. So, so what is the trade-off between small and batch? So it's training speed, increasing the speed with a larger batch. Convergence quality can improve the smaller batch, and memory usage, it's tied directly to the batch size. If it's large, or the memory will be full. If it's little, it will maybe, let's say, empty, not empty, but less utilized. And also the generalization, and often, let's say, benefits from a smaller noisier batch. So when choosing batch size, keep in mind your hardware constraint. So use the large batch size that fit in your GPU memory. And also the dataset, with a smaller batch are better for limited dataset. And also the model complexity. So large batches often work fine for simpler, let's say, model. And don't forget, adjust the learning rate. You have to adjust the learning rate with the batch size. And the key here, let's see, the key insight here is that batch size, it's not just about speed, it's about finding the sweet spot between the computational efficiency and model. So performance. And smaller batch often helps model generalize better, while large batches give you stable and also speed. The best choice depends on your data and also hardware and also the goal. I think that's it for today. Thanks for watching and see you next time. Welcome to the guide of mastering one of the machine learning's most fundamental concepts, the Bias-Variance trade-off. Today we will explore this topic through a common interview questions. By end of this video, you will answer such question perfectly and efficiently. And not only that, but also understand this concept that separates beginners from the professional. Let's go dive. So imagine you are trying to hit the bull's eyes here, but you are keeping a mistake in the same direction every time. That's called a bias. In machine learning, bias is when your model is too simple and keep making the same mistakes. It's also using straight rules to measure a curved line, no matter how you try. It's just one will not, let's see, fit. High bias cause underfitting, where the model fails to capture the uh, let's see, specific patterns in your data. Remember, bias is the being consistently wrong. So as you can see here, the bias is high, but most of the hits, let's see, are in the same direction. But here is scatters, not only in one direction. But this is a high bias. And before uh, uh, going to dive into bias and bias. Bias is related to training. I'm just trying to make it simple. Bias is related to training, and variance is related to validation or testing. And let's say you are training, your bias is high. It means the training data, it's not, let's say, stable. So it's now underfitting. We will see the in with some examples and illustrations. And the next is what is the variance in machine learning? So now you are now picture throwing the dots at a board and they scatter all over the place. Let's see, right? And some near to the center and some are far away. So that is variance. In machine learning phase, in when your model is too sensitive to small changes in the training data, it's like a student who memorize exact answer for practice test but can't handle slightly different questions on the real exam. If the teacher just changed the question slightly, he will not able to answer these questions. So high variance cause overfitting, where your model learn the noise instead of the signal. So remember that variance is about being inconsistently right. So as I mentioned in the beginning, the bias is related to the training, and the variance is related to the validation. So now, if the bias is high, it means that is overfitting. If the variance is high, it means it's no, sorry. If the bias is high, it means it's underfitting. If the variance is high, it's overfitting. So the variance, let's say you are training the model and it was working perfectly on the training part, but for the validation, the variance was high. It means the model is not able to work on this validation data, but it work well with the training data. So, so how do bias and variance contribute to overall, let's say, error? So think of a model error as a simple recipe. It's a total error. You can see the total error is bias square. This is the bias square plus variance plus irreducible error. The irreducible error is the like that the noise you can't eliminate. So you can see, for instance, the 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 irreducible error is, for instance, in this point, even if you try to reduce these errors, you will not be able to, let's say, eliminate this. This is, for instance, this. So no matter how good your model is. So bias square represent how far your prediction are from the true values on the average. And variance show how much your prediction would change if you use different training data. I mean, training data, it means training, let's say a batch. And the magic happens when you find the perfect balance that minimizes the total error. It's like adjusting the temperature and time when back. So you get let's say both right, and you get perfect result. So let's just see this incredible, let's see, figure. So when you start the training, the error will be, let's see, so high, very high, and it will reduce by, let's see, by the time, if it's let's see, we are assuming that it's working in a good way, it will be reduced, and for the validation it will be the same, and every time it will be reduced until this point here. This is the optimal balance, and until this point here you can see the model is perfectly working. And for this black curve here, it is the total error. So for instance, in the beginning, it is this one plus this one here. I mean, this is the total error. This is the curve of the total error. And what is the difference between high bias and high variance? So let's use the our let's see, pulse eye analogy again. A high bias model, it's like high bias. When you say, let's say you have a data, and this data has a different, let's say, distributions, and the model itself can capture the patterns, the hidden patterns from these data, so it will be now high bias. And the high variance is when you, let's say, for instance, this is the high variance here. So when you see you have training your model and the error in the training, it's really close to zero. But when you try to predict something, you have totally different, let's see, an unexpected result. So this called variance. And the idea is, let's say, to make it balance between this and this. We have already seen in the last video. So maybe the question is, what is the trade-off between bias and variance? So the bias and variance test is like, give me 1 minute, please. Yeah. So the trade-off with bias and variance trade-off. So if you make your model more complex, it will the bias will be decreased, and if the variance, let's say bias decreased as model complexity increased, and variance increased as model complexity increase. So we have seen the previous slide, the optimal point is minimizing the total error, this one here. We need to minimize this total error here. Okay, so for underfitting, let's say high bias, both training and validation. Where is this? Yeah. For underfitting, high bias, let's see, both training and validation errors are high. It's like a student who fails both practice test and also the real test. For overfitting, let's see, high bias is training error is low, but the validation error is high. So it's like a student who ICEs, let's see, practice test, but fail in the real test. The solution for that, for underfitting, make your model smarter. For overfitting, simplify your model to get more data. So how can we detect the the underfitting and overfitting? So detecting underfitting and overfitting is like being as a detective. So look at your learning curve. For instance, you have the learning. For instance, if you are by using PyTorch or Keras or anything, so you will have a curve like this, and they tell you the whole story indeed. So for overfitting high bias, both training and validation errors are high. And for the overfitting, the training error is low, but the validation error is high. So the solution for that, for underfitting, make your model smarter, and for the overfitting, make your model, let's see, get more data. And you can see here the solution for underfitting: increase the model complexity, add more data, reduce the regularization, and also feature engineering. So, for instance, select some let's say representative features. And for the overfitting, decrease the model complexity, add regularization. So you have to add penalty for the model, get more data, and for instance, early stop. If you already, let's see, reach this overfitting, you have to stop the model. Okay. So the last one, I think, the last one is how can we balance bias and variance in practice? So to balance bias and variance, you have several, let's see, tool in your, let's see, toolkit. So cross validation is getting multiple opinion before making a decision. So one is cross validation. So the second one, so for instance here you can see cross validation, use cross validation to evaluate performance. And the second one is regularization. It's to add penalty to your model. It's L1 or L2. And this is to combine between L1 and L2 regularization. So I will let you know what is the difference between L1 and L2 and when to use this and this in the next video, maybe a couple more videos. And the third one or fourth one is uh, ensemble methods, combine multiple models. So you try to, like, for instance, random forest. How is it working? It's trying to build different trees from different, let's say, subset of the data set. This will reduce the overfitting indeed. And also you can use a gradient boost, combine multiple models. So I have also, by the way, this explain this with real numerical examples. It will, I'm quite sure that you will understand this if you go to this stuff. And also you have data. So more data, more training data, reduce variance, and also feature engineering, and also data augmentation. It's also for small data set. If you have a small data set and you would like to get a best model, you have to generate data, some images using data augmentation. And best practice, always use validation separated from the training. So when you try to build your model, try to split the in the beginning before the training, training, validation, and test. So this has to be separated from each other. This is you will understand. And oh, by the way, they all of this has to be in the same, let's see, the same distribution. And also monitoring the curve, the learning curve to detect bias and variance. And I think that's it for this. Hopefully this was clear and will help you in the for your interview. Thanks for watching and see you next time. The real life, all datasets, let's see, are imbalanced dataset. So class imbalance happened when one class in your dataset is, let's see, very less compared to other classes. Think of this like fraud detection or maybe tumor detection. Most of the transaction are, let's see, okay, but only a few percent, let's say 0.1, 0.2, 0.3, are, let's say, fraud detection, fraudulent. Or maybe let's see MRI images are most of them are, let's see, okay, but less specific, less small percent are, let's see, have, let's see, a tumor. This is just an example. And if we ignore this, our model become biased, predicting almost everything as non, let's say, fraudulent, or let's say all MRI images are classified as okay. That's just a big issue. So now, how to fix this issue? There are three different, let's see, scenario strategies. One is a data level methods. So it has, we can say, offer sampling, which is create a authentic example for the minority class. And also the and sampling is trying to reduce the majority class, just taking some close to, for instance, to the the minority class, and maybe combine both of them. And for the algorithm level, we can use a class weighted to penalty mistake of the minority class. So you can use weighting, class weighting. Also cost sensitive learning or ensemble methods when you let's say would like to use imbalance. So you can use, for instance, random forest algorithm. And the third one is evaluation method. Accuracy alone, please avoid accuracy in imbalanced data. Accuracy is misleading. And instead focus on matrices like F1 score and the curve, precision recall curve. And analyze your, let's see, confusion matrix to really understand the performance. Accuracy, it's not a good measurement in for the imbalance dataset. And so remember, class imbalance is not, let's say, an easy, or let's say most of the dataset in the real life are imbalanced. So for that you would like for sometimes you will ignore this classification and use unsupervised learning, for example, anomaly detection. And I think that's it for today. If you have any other question, please drop it down in the comment below and we will discuss it. Thanks for watching and see you next time. Eva wondered how to truly test your model without cheating. So cross-validation is your honest friend. Why you have to use it? Because simply splitting the data once can give you lucky or unlucky results. So this slide, let's see here, is just showing you three types of cross-validation. It is key-fold, which is dividing the data into key parts, assuming that this is the data, our data here, and this part will be, for instance, for testing, and the rest of the data will be for the training. And almost this one here is the same. This is for testing. I mean, this is the training, and this one for testing. So you can see this is the testing. And key number of key could be from 1 to 10. I mean, this is, let's say, the from 5 to 10, the most, let's say, recommended one. And the second one is stratified, which is splitting the data and maintaining balance, class balance. And also time series, which is respecting time order. So if you have a data set and let's say it's recording daily, and you would like to split the data set, so you have to take, for instance, today, tomorrow, and etc. So you don't need to mix this here, because each data, its record, it depends on the previous one. So this is you have to take into account. So it's a temporal order. And when to use each, so key vault is general use cases, and the second one here is used for the imbalanced data set, and the time series is if you respect, let's say, to temporal order. And so, what is the key point? Say reducing the overfit, and the most important, it's more reliable evaluation. For instance, for the key, for the first key vault, so you have, for instance, in this one here for the key vault, you have 5 experiments, and assume that you will have less accuracy here, or less performance, and here you will have better, maybe less better, and it's more reliable evaluation, and also better data utilization, model selection, let's see, confidence. That's it for the. If you have any question, just drop it down in the comment below. Sometimes you have a small data set, and but you still would like to use, let's say, for instance, a deep learning to predict, to work on your data here. And the solution here is data augmentation is your magic, let's see, tool. So why we need to use it? Because deep learning models crave data, but collecting and labeling is expensive. So this slide is just showing you some of the, for instance, you can see here, we can use it for the image. You can, if you have a small data set, you can rotate the images, flipping, cropping, and scaling. So in this case, you will have a big data set. For the text, you can synonym, replacement, back translation. For the audio, you can space change, pitch shift, noise injection. And here we have, for instance, a sample of image. So you have, for instance, this image here. If you see here, you can see horizontal, vertical, rotation, and cropping, grayscale, dark. And this you can see here from this image here, we have 10 images in this example. And this is, for instance, the benefit of data augmentation is reducing overfitting, because you will collect much, or let's say a large data set, and also improve generalization. So instead of focusing on, for instance, in such image like this, the model will try to generalize on these all the images here and create a robust model. Let's say it is a compensation for the limited data. It's because if you have a small data set, this will solve your issue here. And the data augmentation is increased data size by creating modified copies of existing data, significantly improving model performance without, let's see, the fact that collecting a new sample. Sometimes you will not be able, let's say, to get new samples, or maybe it's hard to get new samples. So this is the solution. How to, they will ask you, for instance, what is the data augmentation? Yeah, I think that's it for today, and thanks for watching. Let's talk about data versioning, your way to track data evaluation. So why we need to version data sets? So first, it's for reproducibility. So without versioning, you may run the same experiment twice and end up with the different results. Second, for team consistency, everyone in the project should be working with the same dataset, not outdated copies. And it's also provide a clear audit trail. So uh, showing how your data has changed over time. And importantly, versioning gives you a rollback capability. So you can always return to the previous data sets if needed. And now here we have some tools to do this, popular tools. It's like a data versioning control, which is DVC, and think of it as a gate for your dataset. It's indeed versioning. And also for the Git large file storage. So sometimes, let's say you are already familiar with Git and GitHub and everything. But if you would like to track a large, very large files, it's you have to use this LFS. Otherwise, it's hard to track all of these large, let's say, file. So large file storage is just making, let's say, as a pointer. And for instance, the last one, for instance, Git like version lake file storage. And the key insight is that dataset versioning builds a complete history of your dataset. It changes. This means you can run reproducible experiments, collaborate effectively with your team, and also scaling machine learning overflow with confidence. And we already have seen this in the MLOps course, so you can see if you let's say try to load different data, I mean let's say data set, the same data set two times, it will try to create another version. And yeah, that's it. So if you have any question, just drop it down in the comment below. Thanks for watching and see you next time. Decision tree is a super fast algorithm and also used for classification and also for the regression. So the classification, you have a categorical class label, and regression you have continuous value. And now the question is, how does the tree decide the best split? For instance, you can see this is the root and this is the split. How they decide on this stuff? So because sometimes it's use something called information gain, which measure how much split reduce uncertainty in the data. And there are two, let's see, methods come in. It's Gini impurity, and also entropy. So the Gini impurity is about class mixing. It's fast to compute and range from zero perfectly pure to zero point 0.5 completely, let's see, mixed. So think of it like sorting let's say colored ball. The more one color dominate, the pure your set. So and the entropy on the other side measure, let's say the disorder, the disorder or uncertainty in the data set. So it's a bit more computationally intensive, range from zero, so for instance no disorder, or one maximum disorder. So it's like detective waiting how unpredictable the let's say the clue before making let's say a call. And as you can see, this is the Gini impurity. This is the uh, formula of calculating this, and here's the calculating for the entropy, and this is for the information gain. And for that, I have also uploaded a video explaining the decision tree for classification and regression with a really simple numerical example. And I'm quite sure that you will understand everything 100%. And if you have any question, just drop it down in the comment below. I will answer it definitely. Thanks for watching and see you next time. Training model is a lot like studying for an exam. So study too little you are underprepared. If you study too much, you will memorize detail that does not, let's say, matter. So the same happens in machine learning, and that's why we use early stopping, which is one early stopping. It's one method to prevent, or let's say to prevent the overfitting. And uh, this is, let's say, overfitting. And how does it work? So in the first step, we have to monitor, let's say, the validation loss, checking the performance of unseparated, let's say, validation during the training. Next, we detect the plateau. So stop when validation loss stops improving for specific, let's say, of ebooks. So if you see for specific, let's say for 10 ebooks, you can see the condition. If the validation loss is not improved in this, let's say, 10 ebooks, stop. And also maybe if the validation if the loss is trying to let's see degrade, or let's see decrease, try to stop, because in this case it's already overfitting. And the next finally we restore the best weight, so rolling the model back to the point where it performed the best. And the benefits are, let's say, powerful. It's preventing overfitting, save resources, and instead of training 2 days, you need 2 hours, let's say. And also automatic model selection. So based on the loss function, you can save, let's say, for every 10 ebooks, you will save the best model. And also the one advantage or benefit is reducing the the time. And here's the key: early stopping is more than just efficient. It's like a regularizer. So helping balance the variance trade-off without making your model architecture more complex. In other words, early stopping it teach your model the same lesson we human often forget. Sometimes the smartest move is knowing when to quit. I think that's it for today. If you have any question, just drop it down in the comment below. Thanks for watching. Sometimes a single model just is not enough. Imagine asking one person for advice. You might get biased or incomplete answer. But if you ask a group of experts and combine their knowledge, you are more, let's say, likely to get the right solution. So that is the power of ensemble learning. Let's say it's called also the wisdom of crowd applied to the machine learning. So there are, let's see, two different steps. It's bagging and also boosting. So the bagging, as you can see here, the bagging models are trained in parallel, each one on different random subset of the data. So their predictors are then averaged or voted on. So the goal of this bagging is reduce variance and improve stability. So a great example of this algorithm for bagging is random forest. So random forest is ensemble and also bagging algorithms. So we have already discussed this in the last videos. And the next one is boosting. And you can see starting with one, let's see, models are trained sequentially. You can see classifiers. And each new model focuses on correcting the error of the previous one. The goal is to reduce the bias and make the overall prediction stronger. Example of this as like ADA boost, adaptive boost, or XG boost, extreme G boost. And the benefit of ensembling are, let's say, clear. So you can see improve the accuracy, reducing the overfitting, beta stabilities, and also handle complexity. And yeah, so Just the key insight here, Ensemble combine multiple models to produce better prediction than any single model alone. By reducing errors and improving generalization, they also set uh, benchmark in a in a machine learning competition and also in real world applications. So remember, machine learning, it's not just like in our life. Let's see. Sometimes the smart move is not to rely on one device, one voice or advice, but to trust the power of many. So I think that's it for today. If you have any question, just drop it down in the comment below. Thanks for watching and see you next time. So what is the difference between YOLO and faster CNN? So uh, YOLO, so it's stands for you only look once. So it's a real-time single stage detector that does everything is in only one forward pass. So it's dividing the images into grids, predict the bounding boxes and class probability directly. So there's no region proposal steps here. So that's why YOLO is super fast and it's detecting around 30 to 40, let's say 45 frame per second on a GPU. It also depends on the input image size. And let's see, but there's also a trade-off. It's let's see sacrifice a bit of accuracy for let's see, it's somehow giving you a low accuracy for the speed. So it's very fast, but it's let's say not accurate. But it depends also on the application, depends on in the images and the training. But with the new versions of the YOLO, it's now YOLO 12, so it's more optimized, and I mean the accuracy is also more optimized. For the fastest RCNN, it has two stages. So let me just move the sound here. So the first one is region proposal network. Find where the object might be. So they try to, let's say for instance, sub detecting the sub sub regions here. You can see this is the region proposal. This is the first stage, and it's randomly selected these regions, and the next the next step, the network classify and refine those bounding boxes. So this make it more accurate and better at localization, but it's very slow. So you can process 7 to 5 frame per second on GPU, and also it depends on the image size. And so YOLO, it's speed. Faster CNN is accuracy. So if you have been asked for, remember this, YOLO acts fast, and faster CNN, let's see, think deep. I think that's it for today. And by the way, if you would like me to explain one of these algorithms in a more detail with very simple, let's see, numerical examples, just let me know in the comment below. Thanks for watching and see you next time. Branching is not just about Git commands, it's the heartbeat of your team cultures and the engine of your delivery speed. So in today's video, we'll try to focus on what is, let's see, branching, GitHub branching strategy, and final slide will be about the Azure DevOps. And this will be, let's say, somehow theoretical part, of course, with some comments. But if you would like to have it in a practical example, a practical video, or let's say session, please let me know in the comment. And yes, so, and imagine that you are writing, let's say, a code and just imaging and trying to make, let's say, releases. And if it's not organized, it will be a chaos. And get it wrong, and you are looking, let's say, at a chaos, delay, and broken production. And get it right, you will unlock predictable release, scalable collaboration. The choice is yours, and today we will see how to choose, let's see, wisely. So why we need indeed why the branching, or let's say the strategy, it's matter. So because it's, let's say, delivery speed, and if you did it in the right way, you can, let's say, predictable. You can create predictable releases, scalable collaboration, and all the team will work without any, let's say, conflict or issues. And why it's, let's say, branching strategy is matters. So a good branching strategy is like a well-organized city. It prevents messy traffic jam, or maybe keeps, let's say, the down area, for example, the production is stable, while allowing existing new development, for instance, experiments, and let the multiple team work simultaneously without blocking each other. Plus, with the clear street, let's say, sign, if street sign, let's say it's a branch name, everyone navigate faster. Let's build, let's see, a clean, let's see, GitHub, or let's see, strategy. And if you have, see here, this is the branch types in GitHub, and the permanent branches you have to have, it's a main, which is production ready, and development, which is integration. So now you have to have in the beginning main and develop branch. Okay, and let's see the main. It's you can create a release from this main branch, or let's see, release or tags. And if you would like to update, or let's see, add a new features, for instance, if you have to add a new features, you have to create branches from develop. So the main branch won't be touched. So just try to keep it as a production ready. And once you have finished development, you can see, you can, let's see, merge to the main. We will see it in a minute. And this is the feature, which is if you would like to add some features. This is bug fix, when you have to fix some bugs in the code, for instance. Now from here we can, let me just see if I have, okay. So this you have to create it from develop branch. This one here, bug fix as well from develop branch, and hot fix. It's this is, for instance, urgent. Let's see, the system is already in production, and they detect, let's see, some issues, and from this you have to create a branch from the main branch, because the main branch is the one that's used in the production, and try to create a bug fix from hot fix from the main branch, and for the release it's also from the main. And here, if you have a maintenance task, and for the documentation, just use documentation updates, for instance. It's used for documentation update. Now let's see how to name the naming convention. So if you have, let's say, a bad naming, so imagine that you are working with a team, and I will just say this name here, bug fix bug, and I will not able to see what is the bug. Let's see, unless I have to check the code, or maybe let's see new features. Of course, I know it's a new feature, but what is about uh, what are you doing in this new branch, and or maybe this one here. And imagine that if it's like this feature login page. So in this, it will give you indication that this is doing, for instance, for login page. And if it's bug fix, crashed on startup, a hotfix, payment timeout, release, blah blah blah. And this one here, it might be clear. So it's also for me. It's when I develop, let's see, my public GitHubs. I just when I develop alone, I have just to make some random names, which is very bad, I will say. But when I'm working with colleagues and team, it has to be, it's a mandatory to have to follow some meaningful names. And you can see, for instance, here, descriptive feature login page, or maybe this one here. It's not clear. So the main should be reflecting what is the let's see, the working behind. IOC. And this is a work example here. So as we see, we have, let's say you have to develop a new feature. And here you have this git check out develop, or let's see check out develop. As I said in the beginning, if you would like to have it a practical example, I can do it in a live session. And here we are checking the develop branch, or let's see, open the develop branch. Now we are creating a branch, let's see, called feature user authentication, for instance, from the develop. And I will do my stuff. Let's see, the developer, feature user authentication, for instance, and do the changes and everything. And now I will push these changes to this branch, feature user branch. Sorry. So I'll make changes, commit, and push to the remote. So this the new updates or the new branch will be on the Git. Let's see. Now after testing, let's say this one here, this branch, I need to merge this. Let's say to use it in a develop, or let's say in a production. But I will not directly jump to the production to the main. I have to open a pull request to develop branch, because this one here is created from a develop branch. It has to be merged first to develop branch. Now I have the pull request, and in this pull request I will have CI/CD check. Maybe I have just to show you this one here, for instance, when I add stuff. And you can see, for instance, Anoma Vision, and you can see the pull request that I have done, and you can see how many pull requests, and for instance, updates, documentation, for instance. And in this case, you can see the, the template, let's see, pull request. And in here, I have also the pipeline. Yeah, and you can see here I'm testing the code when I have new development and I would like to merge it to a develop or to the main. It has to go through let's see some steps. As you can see here, for instance, I'm testing in 3.9, starting up the job, install it, let's see, set up the Python, install the beauty, blah blah, install the dependencies, run test. So this is the how, okay, this, so this is run some unit tests that will see if the system is not crashing, or and etc. And I will, if this finish, I will start it's automatically, this one, it will be automatic done in the Git. And after this I will check, for instance, all of these Python's version. So in that, if it's everything is fine, we can just, you can click from here merge. And yeah, as I said, we can do this as a live session, why not? And now this is a CI/CD check, code review. Sometimes you have to let's see, to make the code consistent between, let's see, in your team. So for instance, when I run my code, sometimes I had, let's see, add some extra spaces, extra import, for instance, packages that are not being used. So in the check before the commit, this will be fixed before merging this, let's see, some it's not errors, it's, let's say, I would say it's issues to the production. So after the develop branch, now I will try to merge, if everything is fine, I will merge it using a pull request to the develop. Then I will try to make a pull request from the develop to the main, integrating from yeah, of course. I mean, this open a pull request, check, and if everything is fine, it will merge to the develop. Then I will try to make another pull request, and to develop to merge develop to main branch. And please keep in mind that develop and main branch have to be protected, and it means you can't push directly to the main. except only with pull request. So there are three, let's see, three or four steps to merge, and it's merge commits, which is let's see here if it's showable here. Go to here, then to settings, and you can see the not this one. Allow merge commits, squash merge, and also rebase merging. So these are three, let's see, steps, and the last one is fast forward. And this one here will try to create after merging, it will try to create a new commit, which is will be empty indeed commit, and this rebased with it just, as you can see, it's just a linear. This one here, linear history, and this one here is squash. It will just will give you a single commit. I mean, all of these comments that you have done, it will be in one commit. And please, I just forgot to mention this. Each branch, let's see, let me just go to this. This a short life branch, and each branch, let's see, it just has to do only one thing. For instance, if I have say login page, this only has to be focused on login page, and it has nothing to do with the startup or any time out or nothing, just only focusing on this. So, and if you fix this, push it to the git and do the pull request merge and etc. And if you have any other issue, create another branch for a specific issue. So that's why it's a short-lived branch. It has to be only short time. And if you would like to merge from develop to main, you have to, I mean, not you have to, but it's better to use fast forward only. So this will prevent from adding extra commit, let's see. And how to handle a hotfix. So sometimes we already see it in the beginning. If you already in the production, your system is running, and after a while you have some issues or let's say bugs. So this you have to create hot fix from the main, fix this. Let's see this branch. You have hot fix. Now merge it, fix, pull request, merge it to main and develop. So the main and develop will have all of these. This bug hotfix, because if you just merge it to the main and the develop will after a while it will try to merge develop to main, this will be let's see removed, because it's like we will take the new development, let's say the new changes from the develop to branch, and if they are hotfix, it's not in the develop as well, it will be removed. And you have now, and after that, you have to create another release and deliver the new release to the customer. Okay, and best practice, keep branches short-lived. Always use a pull request, and also try to use a specific, let's see, solve specific issue for each branch. Sometimes someone will say, I will create many branches, but it will save you a lot of time. And protect mean and develop automatic. This we have already said that it has to be protected, and this will have automated with GitHub actions, and in Azure it will be pipeline. It's almost the same, I would say. And try to write a meaningful commit messages. And I have, for example, for me and also in our team, we also follow, for example, this one here. Let's see, read me. And this one here changes. Is it a new feature? Is it bug fix? Is it refactoring? Is it performance improvement style? You just need to click, for instance, like this, and checklist. Did you build? Let's see. Did you create test cases? If you If you develop a new branch, you have to, let's see, create a test cases for your development, and also is the documentation is updated, so you have to create select this, for instance. And this I have already done, let's see, uploaded the videos on this. And if something is not clear, please let me know. I can do another video. And also here documentation is updated. If you have to add a pull request, you have to follow this, for instance. Also, you have some guidelines here, for instance, for checklist, so you can see how the things is working and etc. So this is, I'm just trying to add here what I'm using also in the let's see a private, or let's say in a company. And branching, let's see, health checklist. Short life branches, accept mean and develop. Consistent naming, pull request review enforced. So yeah, pull request. So when you have a pull request, you have to add, let's see, a reviewer for this. And I don't want to waste time, but we can do it in another session, a live session, and I show you all of these stuff. And CI/CD automation. The final, let's say, recommendation: permanent branches, mean and develop. Short feature bug, hot fix and release. Merge for sync, for clean sync, use fast forward. But for mean and to develop, to from develop to mean. And also pull request reviews plus automation. And let me just go to the DevOps. I have also a DevOps playlist. So it's not different from here, but maybe it's, if you are interested in this, you can have a look on this. So this, for instance, you have to enforce pull request, code reviews, and build, and also how to create. Now, if in a GitHub, they already have, let's say, some PCs, computers, and you can build your system on the cloud. But for some reason, let's say you need some, let's say, privacy. Sometimes you have a sensitive data you would like to build in your side, so you can also create this. But I haven't in GitHub tried. But in a Azure DevOps, I have created my private build agent, and they have test CI/CD for automation and building everything from in my side. And I think that's it for today. If you have any question, just drop it down in the comment below, and I will answer it definitely. Thanks for watching, and see you next time. Imagine you are standing on top of mountain, blindfolded, and your goal is to reach the lowest valley. That's exactly what the gradient descent is, a step-by-step process to find the optimal path for the minimum of loss function. And there are three, let's say, different ways to take these steps. This batch gradient descent use the entire dataset for each update. It's stable but slow, and also resource consumption. If you have, let's say, a small GPU, and you will not be able to update load the whole data set into a memory for updating the weights, let's say, for back propagation. And the second one is stochastic gradient descent. Take one sample at time. For instance, if you have 10, let's say, million record, or let's say million image, and it will try to read the first image, do the forward propagation, and update the uh, do the back propagation to update the weights, and then input the next image. It will try to use the newest, let's say, weights, and do the forward propagation, and after that calculating the loss and updating the weight only with one sample. This is stochastic gradient descent. It's faster, of course, faster, but noisier. Imagine you have to update every time with each sample the weights. It will not be stable, let's say. And the last one is mini batch gradient descent. It's combining speed and stability. So for instance, you can see I need to update the weight with batch size. Each time it will load, for instance, 5 images, 10 images. This is n, for instance, n samples. And but here's the tricky part: the learning rate, the step size you take on every move. If it's too low, if the learning rate is too low, you will scroll slowly. You'll move. I mean, your movement will be slowly. Maybe even got stuck before reaching the bottom. And if it's too high, you will overshot the valley. Let's say maybe you will move in another direction and might be, let's see, never converge. And but when it's just the right, you guide smoothly to the minimum with efficiency and precision. The key insight is this: the le- oops, the learning the learning rate is the most critical hyperparameters is ingredient descent. It decides whether your model converges to an optimal solution or fail to learn together. So remember, master ingredient descent, it's not just about the algorithm. It's about finding the right learning rate. And there are several, let's see, strategies how to improve, how to update the gradient, the learning rate, and we will see this in the next videos. I think that's it. If you like this video, please subscribe into my channel, like the video, and of course, if you have any question, just drop it down in the comment below. Data is the most important in any system. If you have a better data, if you have a good data, you'll have a good result. If you have bad data, you'll have a bad result. And in this here, missing data is like a puzzle, and you would like to, let's see, to find a solution for this, let's say, empty space. So how you fill them change everything. So why we care about missing data? Because most of the real world data set have a gap, let's see, gaps, and how you handle them affect the model performance. So in this slide, we will try to explore techniques for for instance, deleting when your data is missing, to imputation, for instance, using mean, median, and for the numerical data, and mode for the categorical data, and to advanced methods like KNN and regression, and when to use each. For instance, you can use for the deletion when you have plenty of data. If you have a big data set and you have, let's say, to remove the missing values, so you will still have a big data. But if you will, after removing the data, you will have, let's see, a few records. It's not, this is not a good solution. And you have to choose another one to, for instance, imputation, for instance, calculating the mean, calculating the median, and maybe the mode for the categorical data of the columns. And you could also try to find a pattern, for instance, missing. Try to find the patterns in the data itself, in the data, using KNN, and maybe I don't know, maybe another algorithm just to find the complex patterns to fill this data here. And if you see here, we have technique, deletion, simple mutation, model based. You have to, let's see, create a model that can predict, let's see, the missing values, and also deep learning matrix factorization. This is how to handle missing data. Thanks for watching, and see you next time. You might be asked, imagine that you have hundreds, might have a data set with 1,000 rows and 500, let's see, features. It sounds easy. That's a high dimensional data. It's not a high dimensional, but they will tell you, for instance, millions of records. And if we are not, let's say, careful, we are building risk building a model that overfit, loss interpretation interpretability, I mean you cannot interpret the result, and just not does not let's say generalized. So the first step is always to do is data pre-processing. We handle missing values, normalize features, and also remove duplicates, remove nuns, and etc. Cleaning data is like it's a solid foundation that makes everything else stronger. So if the input is rubbish data, the output will be rubbish. If you have a clean data, you will have a clean result. So the data pre-processing, the data itself, it takes, let's say, I would say, I read it also in some papers that is data is about 80% of your project. And the next one is feature selection. So because we have 500 features, I will say it's not that big, but most of them are not useful. So I will try to look, let's say, low variance features that to be removed, and only select the most representative features, so that can, let's say, represent the whole data itself. So now we can use feature selection. Maybe you could also use dimensionality reduction. You can apply principal component analysis autoencoder to reduce the feature space and make the, let's say, algorithm run with a less resources. And after that we can start to build a model, starting building a model with regularization models. And for me, I personally, I start when I have a new data. I won't, let's say, start with I will not start with the deep learning and blah blah blah. So I will start with linear regression if it's regression, if continuous value, or maybe logistic regression, and study the data, study the performance. And if you would like, for instance, if the accuracy is low, we can now start to improve the accuracy. And from that point, you will understand what you would like to improve. And this is my, let's say, strategy when I have some, let's say, a new project. And that's it for today. And if you have any questions, just drop it down in the comment below. Thanks for watching, and see you next time. The regularization is one technique to prevent overfitting. And let's see what is the regularization. So they will ask you what is the regular and the regularization L1 and L2. So regularization is a technique to prevent overfitting by adding penalties to complex models. And why we need it, as I said, that it's just sometimes the training data is working perfectly well, but it's not working with the validation or test dataset. So it's not, let's say, generalized to the whole dataset. And there are two different regularization models, let's say, methods. It's one L1 lasso and rigid L2. And L1, as you can see, it's somehow adding penalty to uh, to equal the absolute value of the coefficient. So it starts creating sparse models. So most of the coefficients will be closing to maybe zero, depends on the lambda. And also the rigid one, let's say rigid or L2, it's adding equal to a square coefficient. We will see the equations here, and you can see here this is the L1. You have, after, let's see, after the forward propagation, we have to calculate the, let's say, the loss function and everything. And after that we will add this lambda and the coefficient L1 and or L2. And you can see L1 and L2, it's L1, it's adding the absolute value of the weights, and this one here is squaring the absolute squaring the weights of the of the of the weight, let's see. And if you see here, the lambda, if lambda is zero, so there is no regularization. If it's infinity, it maximize maximum. The regularization is all coefficients is zero. So we have to this it won't let's say it won't be infinity. And maybe you will ask question, if L1 it's not working, so you have to see we can add L2 with as well. This is called elastic net. And how do L1 and L2 differ in effects? So by the way, I have also one video here which is explaining the L1 and L2 in a free details. Let's see with examples. You can see here with numerical example. So I'm quite sure that you will understand everything here. And the difference between L1 and L2 is that L1 is creating a sparse solution. As I said, if you see most of the, I mean, not some of the coefficient will be exactly zero. So some features will be zero, and the other one will be, let's see, the most representative will be not zero. But here it will use the most, all, let's see, all coefficients, but with different, let's see, weights. And it's used for feature selection, and this one here is keep all features, and here's absolute value and here's square values. And this is let's see how to what is the difference between L1 and L2, and when to use L1 versus L2. So you need, if you would like to use a feature, this is, let's say, to offer it's used for overfitting. And now, when to use L1 and L2. L1, if you need to select features, if you have a working high dimensional data and you would like to reduce this dimensionality to work with your resource, let's say CPU, GPU, and sometimes many features are irrelevant, so it will be removed. So this code, you will have finally a sparse model. But for this one here, if you all the features are potentially relevant, so features are correlated, and you need stable solutions. And so sometimes the L2, the L1 is sensitive, and the L2 is working okay. And for instance here, a quick decision. Do you need to eliminate features? Use L1. Are features highly correlated? L2. Want to keep all features? Then L2. And let's see. And somewhere you ask about choosing between one and two. So mention that you can use, you can also combine them uh, using elastic net. As I said in the beginning, it's elastic net. If, for instance, they will ask why if not L1 it's not working, or maybe L2 is not working, so we can see. I will try to combine both. And here's the summary. As you can see here, penalty type, it's absolute value. Eliminate features, sparse, some features will be zero, and it's used for feature selection. And this is the formula of L1, and this is for L2. And as I said, if you have no idea about these, I have already explained this in another video. I will put it in the description, or maybe in the screen. It will be pop up. So yeah, so of course, if you have any question, as always, just throw it down in the comment below. Thanks for watching, and see you next time. One of the most important decisions in training deep learning models is setting the learning rate. But here's the problem: single fixed learning rate does not always work. So if the learning rate is high, you will, let's say, overshot. If it's low, you will crawl, and you might not, let's see, getting the minimum, the optimal minimum. And that's where the learning rate schedules come in. And they dynamically adjust the learning rate during the training. So for fast convergence, better generalization, and also smart optimization. So you will start with a specific value for the learning rate, but after specific, let's see, interval, or let's see, epochs, the learning rate will be updated. And we have several, let's see, schedulers. So the one here, the first one is step decay. Here's the learning rate drops by a fixed factor at set, let's see, of interval. It's simple, effective, and great for a large data set and simpler model. And the second one is exponential decay. The learning rate decreases continuously in an exponential curve. So it's like perfect for consistent smooth, and convergence. And the cosine annealing, this one is follows, let's say, cosine wave. It's gradually reducing the learning rate and sometimes resetting it. So it's especially powerful for deep learning, for deep networks and fine tuning. And the cyclic learning rate, the learning rate here is goes up and down periodically. Why? Because they because those ups helps the model to escape local minima and find the better, let's say, global solutions. So you can see here, this is the benefits. The benefits of this scheduler is huge indeed. Faster, let's say, convergence, better fine tuning, and also escaping saddle buoyant. And the last one is, let's see, improving the generalization. So the key insight: learning rate schedules give you the best of both worlds. Let's see, high learning rate to speed up the training and low learning rate to find the tune performance. So by adapting the learning rate at the right time, they help you, let's say, they help the models convergence faster and smarter. And also remember, the it's not just about choosing, let's say, learning rate. It's also about to find the right schedule. And as you can see here, let me just move this. As you can see here, for this step, this decay, it's better for large data set, simpler model, consistent convergence need, deep networks, fine tuning, and skipping local minima. And you can see also this is the complexity. And that's it for today. Thanks for watching and see you next time. From the from the title, you can see logistic regression, and you will think this is regression algorithm. It's predicting continuous value, but no, it's not predicting a continuous value. It's used for binary classification, and with help of sigmoid function that transform any output of the algorithm into 0 and 1. So if you imagine that you are predicting, or let's say predicting spam, email spam or ham emails, and with this probability, you will see if it's, for instance, greater than a specific threshold, it will be ham. If less, it will be, let's say, spam, or vice versa. And linear regression is used to predict a continuous uh, values. For instance, house price predicting, or let's say a stock predicting, and the output, let's say the predicting or the target variable, is a continuous value. It's from one, it's, let's say, from 0 to infinity, and maybe. And the logistic regression, the output is trying to predicting categorical variables. It's, for instance, let's say spam or ham, cat or dog. It's, for instance, in this example, if the applicants will default or not. So this is, let's say, binary classification. So this is the difference between logistic regression and linear regression. So the only difference is the sigmoid function that used in logistic regression. I think that's it. If you have any questions, just drop it down in the comment below. And also, I have uploaded two videos on linear regression and also logistic regression with a simple numerical example, and I'm quite sure that you will understand it 100%. Thanks for watching and see you next time. Hi everyone. Today we are tackling something that makes everyone nervous: tough ML and computer view interview questions. Whether you are just starting or you have, let's say, some experience, these strategies will help you to handle any question with confidence. So, in the next few minutes, I will share with you practical tips that are easy to remember and also implement. Before diving into this, just remember, an interview, it's not an exam. It's definitely not the end of the world. If you didn't know something, for example, if you didn't have an idea about something. So in machine learning and computer vision, the field is huge. Nobody knows everything. So sometimes the interviewer may focus on a topic that you haven't worked with, and that is, let's say, completely normal. In fact, you might even know more in other areas than the person interviewing you. So what really matter is not having every answer, let's say, memorized. It's showing honestly, logical thinking, and also willingness to learn. That's what makes strong ML and computer vision engineer or research. So take a deep breath, stay confident, and remember, not knowing one question does not, let's say, define your skill or your career path. So be confident. So let's start. Okay, so when you faced with tough questions, remember these four keys. First, be honest. So never answer a question with random information. So the interviewers appreciate honesty. So second, stay calm. One question won't make or break your interview. Third, show your reasoning. Just see how you think matters more than perfect, let's see, recall. And the last one is uh, pivot to strength. So connect what you didn't know to what you already know. So these four steps are your foundation to handling any tough questions. And sometimes even if you have two questions that are, let's say, far away from your stuff, but let's just be honest. If you, let's say, if the company is focusing on, let's say, object detection, and I will just suggest that you have experience with at least YOLO or maybe fast RN, RCNN. So if you are not able to handle this, I would say it's a problem, but it's not the end of the life. So sometimes you have no experience, but you would like to get some experience from these interviews. And I will say, don't be, let's say, frustrated. Just collect some information from several interviews, and I'm sure you will definitely catch a job. Now, what you have been asked about a skill or tool that you don't know, let's say. Simple formula: unknown, known, willing, willingness to learn. So imagine someone asks you, "What is your experience in a TensorFlow?" So let's say you haven't worked or touched TensorFlow, but you work with some other, let's say, frameworks. Let's say PyTorch. So you say, I haven't used TensorFlow directly, but I have optimized deploy models with PyTorch. So I can adapt quickly since the principle of inference optimization are similar. So in this case, you are honest that you have no idea about this, because if you see, yes, I have this runtime experience, they might ask follow questions, and if you say no, you will stop. They will not ask you further questions in this area, and they will focus on a different areas. So here you see, I'm honest, I have no idea. Then I will be I have another experience with another frameworks, and also willingness. I will eager to learn, let's say, something, let's say, new. And for the other unknown, let's say, topics, so, for instance, they ask you about reinforcement learning. So here's the no acknowledge, transfer skills, and show confidence. So say, that's not my specialized area. My main focus, let's say, is has been anomaly detection or object detection or maybe text analysis, LLMs, and etc. But I'm confident I can pick up, let's see, reinforcement learning using my ML foundation. Maybe one hand. So I have been in an interview, and they have been asking me about CI/CD pipelines, and I haven't here in this term. Never, I haven't seen it or maybe heard it before. So this was before 5 years, and I was thinking, I have no idea what is this, and I said I have no idea, but could you please explain me what is this and how did you use it in your company? And after that interview, I was rejected, of course. After they were focusing on someone his pipelines, let's see, master pipelines. And after that interview, I had got rejected, and from that point, I was focusing on to see what is the CI/CD pipelines, and each project I have involved myself in each project to learn this CI/CD pipelines. So this is just to see, and next time that someone will ask you, you already have a strong foundation or basics, and you already work with this, you will be confident and answer these questions. Let's see the next one. So also sometimes they will ask you about something. Let's say, have you worked with, let's say, with Padm? But as I said in the beginning, if the company is working with, for instance, if they are working with computer vision, and they ask you about LLMs, so in this case, you can see I have a basic, or maybe I have no idea about this, but my focus is computer vision. Sometimes the LLMs transformers they also used for, let's see, they even use for the object detection and also for the anomaly detections. And you just be honest, acknowledge, share reason, and I will say, for instance, eager to learn. And you can see here, I have studied this before, but for instance, LLM, but don't recall every step here. Let's say, for instance, here, anomaly detection. It's an anomaly detection approach that use pre-trained features and Gaussian model. This principle is to model a normal features distribution and compare test samples. And I would refresh this data after the interview. This is what I have done indeed. After each interview, I have written the difficult questions, or maybe the simple questions that I haven't take care about, and review these questions and study it indeed carefully. You have to do this carefully, and in the next interviews, or even they don't ask such questions, but you have knowledge about different topics. So this is what I have done indeed. And if you see you have uh, you know something, but you forgot some any algorithm. For instance, they ask you about, I don't know, maybe, as you can see here, it's I might let's see, a graph traversal. So I might not recall this 100%, but here's my understanding. But if you don't know, let's see, totally no, or maybe basic information, and you have some doubts, say, I have no idea. I have some doubts on this, so I will not explain. So last in one interview, someone asking me what in 2016 or 2017, someone asked me what is how many layers in YOLO, and in that time there are several versions of YOLO, and I was confused which version, and I have said I can see this exactly, but because I'm quite sure I will make a mistake, so I will not answer something I'm not quite sure. And they said okay, and after the interview I got the offer, but I have decided to go to another company. Yeah, and this is, let's see, uh, remember these four golden rules in any interviews, not in machine learning or computer vision. First, honest, in integrated matter. Second, reasoning beat memory. Walk through what you have, what you solve this problem, let's say logically, and learning mindset. So eager, let's say, always show that you are, even if I have no ideas or let's say information about this topic, but I'm really, let's say, eager to learn something new, and try to link what you have know in this. For instance, some questions. For instance, if they ask you, have you worked with Padm? Let's say you are working with batch core, for instance, another algorithm, or maybe several algorithms. See, I haven't working with Padm, but I have worked with blah 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 blah. So this will show you that you know at least this experience, and it's easy to adapt your knowledge to the other, let's say, stuff. So I think that's enough for today. And if you have any questions, just drop it down in the comment below. Thanks for watching, and see you next time. So it would be also, if you could share your stuff or maybe questions that could be helpful for another candidates. Thanks for watching. Big data gets all the attention, but what if you only have small data set? So don't worry, sometimes the small data sets can still make a big impact if you choose the right model. For small data set, simplicity often wins. Why? Because simpler model reduce the risk of overfitting, and also generalized better when you have a limited data. So which model you have to consider, let's say. And linear models, so like logistic and linear regression, fast, interpretable, and often surprising powerful. And this is my strategy. When I have a new data set, I will not jump to the deep learning and maybe, let's say, the smart, let's say, algorithms. I will start to understand the data, and I will start to understand how the model and how the let's say the linear regression is working on this data. And for this, you will understand which you would like, let's say, what you would like to improve, indeed. And the tree-based models such as random forest, XGBoost, and XGBoost is I would say it's your hero. So try to use XGBoost. Maybe random forest is it's working for small data set, but if you have a big data set, this is a different topic, but try to use XGBoost. And also like GMB, they balance flexibility with the performance, especially as your dataset, let's say, grows. And Bayesian approaches like Gaussian processes and knife Bayes, they create when you want to, let's say, incorporate prior knowledge and work with uncertainty. And the k-nearest neighbor, KNN, is a simple distance-based method. So you can it can shine on a free small data set. But remember, model selection, it's not just about algorithm. You need to consider the bias variance, let's see, trade-off. Also, engineering to make the most out of the limited data, and proper regularization, and of course cross-validation to avoid overfitting. The key here is, this is the insight key. I will, so with a small data set, simpler model often outperform a complex ones, giving you a better generalization and faster training without, let's say a big complexity. And I think that's it for today. If you have any questions, just drop it down in the comment below. Thanks for watching. If I wonder what makes neural networks so powerful, it's about the activation functions. The activation function are, let's say, the secret that give the neural network the decision making power. So in this video, I will try to, let's say, to show you three important activation functions you need to know: Sigmoid, Tanh, and ReLU. So by end of this video, you will have the chance to choose the right activation function for any neural network, and also answer the questions in the interview confidently. So let's start. So first, what exactly are activation functions? So imagine you are a neuron in a neural network. So you receive a signals, do some math, and then need to decide whether to fire or not, whether let's say to activate or not. So that's where the activation functions come in. So they are like a decision makers of the neural network. So without activation function, our neural network would be let's say assembled like linear regression models. So and uh, activation functions add, let's say, non-linearity magic to the network that allows neural network to learn a complex pattern and also solve real world problem. So as I said, without activation functions, it will be as the linear regression. So let's see here we have three different activation function: the sigmoid function, tanh, and ReLU. And the sigmoid function, it's used for binary classification. Why? If you have a deep neural network, you will not be use it in the hidden layers, as for example the activation function, because it's vanishing gradient. What does the vanishing gradient means? See, if you have forward propagation and updating the weights called back propagation. So after calculating the gradient, I have also explained this in one video. I will put the description in the link in the description. So after calculating the gradient, some gradients will be close to zero if we use the sigmoid function. So if the weights, or let's say gradient, are close to the zero, the update of the network, it will be, let's say, freezed, or it will need not updated anymore. And the tan edge, it's used for hidden layers, and it's used for zero centroid if you would like to have the data zero centroid. And also it has a vanishing gradient. And for the ReLU, its most use cases we have. Uh, I have always see in any let's say neural network, they use ReLU, which is useful for the deep network. So if you see here, the range is 0 and 1 for the sigmoid, and here -1 and 1, and here from 0 to infinity. So you have the give the network to learn and not vanishing because you have from 0 to infinity. And the housework, it's like taking just the max for 0 or x. So it means it will ignore the negative values. And here it will calculate this tonnage, and this is calculating the sigmoid formula. And here, which activation function should you use? So if you see here, that is the range, and vanishing gradient is for the sigmoid and tannage. And for the vanishing gradient, it's no for a ReLU, because as I did, it has the probable range from 0 to infinity. So the weight won't be, let's say the gradient won't be, let's say 0. Uh, and also zero centroid, here is only the tan edge. And the complexity, the most, let's see, it's not complex, it's just taking the maximum, which is very low. So when to use sigmoid, it's just only used for binary classification. So when you would like to have the probability between 0 and 1, if you have, let's say, to classify an image in a dog or cat, and let's say you'll have a probability, let's say zero point 0.5, or let's say zero point 0.3, zero point 0.9, point something, and you will have, after that you will have a specific threshold, and if the probability is greater than this threshold, it will be classified as this class. If not, it will be the other class. So, and try to avoid, I mean, not try to avoid, don't use sigmoid in hidden layers, because it's vanishing gradient. And for the tannage, it's used for hidden layers, but also we see it's a zero centroid centered output. But also still suffer from gradient, vanishing gradient. But try always use ReLU when you have a deep neural network. And the hidden layers, it will use you will use ReLU. After convolution and polling and this, you will have a reactivation function with ReLU. And we have said that the activation function in general, as let's see, it's the adding complexity or non-linearity to the network to learn complex data. So I think that's it for today. If you have any question, just drop it down in the comment below. I will definitely answer it. Thanks for watching. So you can see here, can you explain how object detection works? So object detection, it's not just one step, it's a pipeline. And it starts with feature extraction. So a CNN extract the visual features from your input image, like edges, textures, and shapes. And then come the region proposal and anchor. This region proposal, it's in faster CNN, but this is in general what are the main steps. And the steps here generate potential, let's say, regions where object might exist. And the region proposed, and in YOLO, it's dividing the images into several regions and try to detect. Let's see, the next step is to classify plus, let's see, uh, bounding books plus regression. So here the network classify what is inside its region and refines the bounding boxes to let's see, for accurate localization. And finally, post-processing, which is using NMS, or let's say non-maximum separation, cleaning up the overlapping boxes and keep only the best, let's see, detections. So the full pipeline is feature extraction, region proposal, classification, plus bounding boxes regression, and finally post processing. This is how to what are the, let's say, the object detection pipelines. Thanks for watching and see you next time. Training a neural network is like navigating a mountain landscape. You are trying to find the lowest valley, let's say the global minimum. But the path you take depends on your optimizer. So we have several optimizers here. So the first one is I can't pronounce this. Stochastic gradient descent. So this is the simplest optimizer. It update the parameters directly based on the gradient. It's lightweight, resource friendly, and often give you better generalization. But it can be slow to cover convergence. You can see this is, for instance, SGD. This one here. And the momentum, think of it like pushing a heavy ball downhill. So instead of stopping at every bump, it accelerates in in the right direction and smooth out the path. So momentum helps with the high, let's see, curve regions and provides more consistent gradient. And you can see, for instance, this is the formula of this one here. You can see best for limited resources, better generalization, and this is for the consistent gradient. So you cannot see, for instance, jumps between this and this. I mean, for instance, better and good, bad. So you can see this, for instance, this is with SG plus momentum. And the last one is this one, ADAM. It's adaptive momentum. So this is the most popular, let's say, choice. And I will just let you know that I haven't used, let's say, momentum and SGD. So this is my, let's say, default optimizer, because it's let's say a default choice. And you can see, for instance, it's speed, memory, convergence, and generalization. It's perfect, I will say. And it's combining adaptive learning rate with momentum. So Adam adapts the step size for each parameter and converges fast, especially with the sparse gradient. So that's why it's often default starting point in a deep learning, I would say. This is the default one. But here's the inside key. Adam is fast and powerful, but SGD or stochastic gradient descent with momentum often gives better generalization, especially when fine-tuning model. So your choice of optimizer, it depends on the problem, data size, and computational, let's see, constraint. So how should you, let's see, proceed? Or let's see, you should choose which one is, as I said, most of the guys, let's see, or the people just use Adam. So use Adam as your baseline for speed and efficiency. Experiment with SGD plus momentum when you care about generalization. And keep in mind your resource and data set characteristic, it's let's see, have to be taken into account. And at the end, the optimizer is your, let's say, pathfinder. Choose wisely and you will reach the convergence faster, more reliable, and also get a better result. Thanks for watching and see you next time. I'm quite sure that you have trained your model and it was working perfectly in the training, but completely failed in the real world, or let's say in the inference. And also, I'm quite sure that you already have been asked about the overfitting. What is the overfitting? How to let's say, eliminate or avoid overfitting. And for me, I have been asked during my interviews. I have been asked this question, and also I like to ask this question for the interviewers. So this called the overfitting, and today we are going to let's see, show you overfitting in the simplest way possible. By end of this video, you will understand what is the overfitting. You will be able to answer such questions, and you will, of course, answer these questions in a perfect, let's say, way. So as you can see here in this picture here, let's see as in a short example. So imagine that you are studying for a test. So instead of understanding the concept, you memorize every single word in this text box. So including, let's see, typos, including even wrong information. So that's called overfitting. So the overfitting, when it happens when your model is able to learn, uh, let's see, all patterns from the training data, but it's not able to, let's see, predict, or let's see, work in a unseen data. This called overfitting. As you can see here, this is, for instance, you have this data set here, and you can see this is underfitting. What does underfitting mean? So you can see the model, it's not able to or let's see, there are several many false predicted, either this or maybe this. And here you can see appropriate fitting. The model is working perfectly on training and validation. Of course, there's some wrong. We'll see, it's not 100%, but this is the best model in this image here. And this is the overfitting. And it might that the model is really complex and has many parameters that can handle every patterns in the data, only the data. And when it's working perfectly on this. But if you have a point here, for instance, a circle here, it won't be able to detect in the testing. Or maybe X is here, it won't be detected. So this is how this is what is the overfitting. And how to stop the overfitting. Indeed, there are several. Of course, you can see here, how would you detect if your model is overfitting. Let's see this is, so large gap between the training and validation performance. You can see this is the train and validation. So you can see the error may be the loss in the validation, it's somehow high, but for the training it's good. And the learning curve, it's decreasing, and while the validation is increased. And also the performance poorly in the unseen data. So this is, let's see, how to detect the overfitting. Now, let's see here, what are the main causes of the overfitting? So there are several factors, let's see. So one is if the model is too complex, let's see how many parameters, so it can be learn every single patterns in on the training data. And also two, the second one is you have only a few data set, let's see, small data set that the model can handle these patterns in this data set, and also some noise in the too much noise in the training data set. And the training also has many epochs. So if you train your model several epochs, this means it will try to memorize the data in the training. And so for this you need to stop, let's see, the training. And you can see we have already discussed this last time. This is the bias, and this is the variance, and this is the error, total error, and here's the optimal here. So we have already discussed this in the last time. Now the question is, what techniques, let's say they will ask, what is the overfitting and how to prevent or fix overfitting? So to prevent overfitting or fix this, you have to have more training data, simplify the model. You can have, let's see, reduce the complexity of the model, and use the regularization L1 and L2, and maybe both, elastic. And L1 and L2, we will discuss this next time. And also apply cross validation to avoid this overfitting. And as we have seen in the previous slide, that if we have training for many ebooks, so the solution here is implement early stopping. So when we see the model is trying to overfit, there's a big gap between the validation and training loss. We will stop the training. And you can see here what are your top tips for preventing overfitting in practice. I will start with simple start, begin with a basic model, don't start with a complex, and always use validation test data to evaluate the performance, monitor matrix, as you can see as you have seen in this one here, for instance. Let's see, you can see you need this graph here just to see the model, and also cross validation, regularization, regularize early. So apply the regularization from the start. So you can see here, this is the anti-fitting, how to fix the anti-fitting, under-fitting and overfitting. Under-fitting, more complex model. It's just the opposite direction. Less regularization here, more regularization. Large quantity of features, smaller quantity of features. More data can't help, and here more data help. I think that's it for today. And if you have any question, just drop it down in the comment below. I will try to make another video for you if it's needed. Thanks for watching, and see you next time. Not only accuracy that can be, let's see, measure the performance of your system. Sometimes accuracy, it's misleading, especially when you have an imbalanced data set. So you can see we have a position recall and F1 score. What are the differences between these, and when to use all of these? So please keep in mind this precision recall F1 is used only for one class. So if you have, let's see, you can see here, I have positive, negative and positive class. So I will see which one is the important, and I will calculate position recall F1 for one class, which is the most important. Let's see, one. For instance, spam or ham. So the most important is spam. For instance, diagnosis disease. Diagnosis disease is uh, positive. It's let's say has a disease. It's better than not having a disease, and etc. Like this. So you have to decide which class is more important, and try to calculate this. So precision is all about accuracy. When you predict positive, it tells you all of the emails. Let's see, my model flagged as spam. How many were actually spam? The higher the precision, the lower false alarm. So if you would like to reduce the false positive, you can use precision. So for it means false positive. Let's say you have a ham email or a good email, but it's classified as spam. So in this case, you would like to reduce the false positive. You can use precision. And for the recall, it's used for reducing the negative, false negative. For imagine you have fraud detection and someone is making, let's say, attack your website, and if you say it's attacking your, let's say, classified as fraud detection, but you classify it as a none, let's say, or normal. So in this case, it's you will miss, let's say, or you see worse, let's say, consequences. So if you would like to reduce false negative, you can use recall. And F1 score, it's the harmonic mean of the precision and recall balance both metrics in a single score. And try to use F score also if you have imbalanced data set. Try not to use accuracy for this stuff. And I think that's it for today. If you have any question, just drop it down in the comment below. I will answer it. Thanks for watching. Why does random forest reduce overfitting compared to a single decision tree? So let me give you this example. Imagine you would like to go to a doctor and you went to this doctor and he give you a decision. For instance, you have, for instance, this disease, and you would like to be quite sure. And what you will do, you will go to another one, right? And to make this result, let's say, more confident. And this is random forest using, this will, let's say, reduce the overfitting or noise if you go to many doctors, right? And like random forest reduce overfitting through ensemble learning and randomization. So it's, let's say, creating many decision trees that collectively generalized better. So if you have a big data set, each tree will use a subset of features and also subset of the data, and this is random. And so this is randomly, each subset will be randomly selected. And if you see here randomly selected, it means it will let's see, reduce the overfitting. And also for the prediction, it will try to use majority voting from all of these random I mean decisions. And it's called random, I mean it's called forest because it has many trees. And if you see here, random forest is lower variance, robust to noise, and better generalization because you have many decision trees. For the in the other hand, is single decision tree is high variance, sensitive to noise, and also prone to overfitting. And if you would like to use a decision tree, for instance, something like a decision tree, like try to avoid decision tree, use random forest. And yeah, I think that's it for today. If you have any further question, please drop it down in the comment below. By the way, every single algorithm is also explained in a very more details with let's see, really small numerical examples. Random forest and gradient boosting algorithms are ensemble methods in machine learning, and both designed to make prediction smarter but in a different ways. So as you can see here, random forest is a bagging, and gradient descent is boosting. And what is the bagging means and what is the boosting means? Bagging, it means if imagine you have a data set, and from this data set you will build independent trees in parallel. And as you can see here, it's a small image, but this is a data set, and try to build a decision tree, for instance here, several decision trees. And the random forest, keep in mind that random forest is reduced variance and also preventing overfitting. And also use random feature subset. If you have a big data set and you will have randomly subset, different, maybe different features, and each subset will try to build a decision tree. And imagine you have it's called forest, because you have many decision trees. And for the prediction, it will try to take the majority vote, or let's say average. For the gradient boosting, it's a boosting algorithm, and it's not, let's see, as a as a random forest. It's built sequential trees that learn from the errors. It's only one tree, but it's only updating, let's say, trying to solve the errors on the previous tree. And this reduces bias and also focuses on the hard example. So imagine you have a data set. You will start to making a decision tree, and with the let's say false prediction, you will try to improve this false prediction from the previous tree, and update it in the next tree, but it's also one, let's say, tree. And it's use gradient descent to minimize the loss, and final prediction will be weighted sum. And these, in both algorithms, I have uploaded the videos with explain every details in a random forest, and also gradient boosting, with really simple numerical example, and you will understand it 100%. So of course, if you have any question, just drop it down in the comment below. I will answer it, or making, for instance, another video for you. Thanks for watching, and see you next time. Imagine you are developing a system that could save lives. Every missed case could have, let's say, serious consequences. So that's exactly when you prioritize recall and precision. And by the way, recall and precision, it's only, let's say, calculated for one class. So please keep in mind. So let's say you have two classes, positive and negative. So you will decide, for instance, which class is very important. So now you can see, you will calculate the recall and precision. And now, if you see here, precision is reducing the false positive. Let's say you are trying to detect, let's see, spam emails, and now you would like to minimize the false positive. So what does that false positive? Imagine you receive an email. It's okay email, legitimate email, and this will, let's say, classified as spam. It's called, let's say, false positive, and now it's annoying. So now we would like to reduce this false positive. So now here we can use, let's say, precision, and recall is reduce false negative. And imagine that you are, let's say, working with medical diagnosis. So someone has, let's say, you have let's say someone has a cancer, and if you miss this classification, if you miss this, it has, let's say, a tumor, and you said no, it has no tumor. This missing positive cases, let's say, disease, can be threatening. So false positive could be acceptable, because we can do further testing. If you classify a one with, let's say, has a tumor, but it has no tumor, so we can stick this with the next exam, with the next test. But if someone has a tumor and you classify it as non-tumor, let's say free, this will has big consequences. So now you need to know when to use recall and precision. And here, this is the confusion matrix. And please keep in mind, recall and precision, it's only used for one class. The other class is neglectable. So I think that I've also uploaded the video on this, so with the real numerical example, and I'm quite sure that you will understand everything 100%. That's it for today. And if you have any questions, just drop it down in the comment below. So in the interview, you might be asked, what is the difference between ResNet and efficient net? So as you know, ResNet focuses on depth. So it solves the vanishing gradient problem using skip connections. Sorry, skip connections here. So you can see here, this is the VGG, this is layers, uh, 34 layers, and this is with a skip connection, and which is let gradient flow through the layer smoothly. So think of the ResNet uh, of like giving the network shortcuts. It's learn the residual instead of the full mapping. So that is show that's how ResNet can train a very deep network, for example, from 50 to 100 or maybe more layers. So without breaking down. So it's just trying to learning this skip. And if the in the back propagation, if the any weight is, let's say, zero, the residual also will be used. So is in this case we avoid the gradient, vanishing gradient descent. I have explained this in more details, so please have a look. I will add it in the subscription. And this efficient network, and after a while, the efficient network is was coming. So it's focusing on balance. It does not just go deeper; it's also scale the depth, width, and resolution, all together using something called compound scaling. So let's move this here, the sound. So as you can see, it's compound scaling, and this gives you a better accuracy with fewer parameters. It's super efficient and super smart. So simply, ResNet solve vanishing gradient and goes deeper. EfficientNet scales smarter for better accuracy to efficiency ratio. So indeed, both are milestones in deep learning. ResNet show us how to build a really deep networks, and efficient showed us how to make them beautiful, efficient. That's it for today, and thanks for watching. So, what is the difference between object detection and segmentation? So, before diving into to answer this question, as you can see, this is the classification. So, if you have input one image, so you can see classify this image, only classification, cat or dog or anything. And for the object detection is going one deeper, it's just to localize which object in this image here. And for the semantic segmentation, it's just, let's see, detect, localizing the object and also classifying each pixel belongs to the object. So let's go down, dive into this. So the detection, it's draw a bounding boxes. This called bounding boxes. And detections tell you where objects are. So, for instance, if it's the cat is here, and for the object detection, it's very fast and great for real-time task, but it has only the location, not the sheep. So you can see some pixels are not belong to the dog, but it's also included. But it gives you localization. For the segmentation, it goes one step deeper. Not it doesn't just find the object. It's also pinned every pixel that belongs to the, the objects. Well, let's see. So every, for example, every pixel of cat is labeled as a cat. You can see every pixel is classified, or let's see, colored in the same way. And so the detections give us the bounding boxes, and the segmentation gives us boundaries. So you can see the boundaries of the and pixel perfect understanding the scene. So detection, where's the object? segmentation what every pixel belong to the object. So I think that's it. And if you have any question, just drop it down in the comment below. Thanks for watching and see you next time. Support vector machine is designed to work on binary classification. So how would it work if you have, let's see, multiple classes? If this is the first time you know this info, please like the video and write a comment. So let's say we will have many classes in our stuff. So by the way, the support vector machine is already explained with real, with a simple numerical example, step by step, and I'm quite sure that you will understand every step. You will finally understand what is a support vector machine. It's apart from the I was simplified the equations with the simple numerical example. So we will skip this here. Now, as you can see, assume that you have a data set with several classes. Let's see here, red, blue, green, or black. Let's say you have a data set to classify animals, dog, birds, and cats. And support vector machine, it work only with binary classification, with only two classes. But now in this case, we have three classes. So there's two options, or let's see scenarios. The first one is one versus one. So we will have, for instance, we have three different classes here. We will build we will build n times n minus 1 divided by 2 classifiers. So for example, here we have 3. It will be 3 times 2 divided by 2. It will be 3. So we will have 3 classifiers. If you have three classes, we will have three classifiers. So for instance, now one versus one, for instance, this red against, let's say, the black, and the red against the blue, and black against red. We already did this, so there's no need to repeat. We will see black against this class. So this is one versus one. So the classifier will be trained on a specific, on the data of these two classes. So if you have a data set, a big data set for animals, and we will select, for example, cat and dogs, we will select this subset of the data and build the classifier. Now, and in the prediction, we have several classifiers. And now how to select the let's see, the answer, let's see, the inference or the prediction. We will see if you have many classifiers, we will see the prediction by majority vote. So the most, let's see, predicted class, it will be assigned to the new sample. And the second one is one versus all, which is create a binary classifier for each class against all. For instance, you have this class here. I will try to assume this is one class, let's say the positive class, and the other samples or the other classes will be negative class, for instance. And also for this one here, we will see this is the class, and the other samples that are not related to this class will be considered as another class, let's say a negative class, and etc. So this here for the training, for the data that we use for the one versus all, we will use the whole data set. And it's also the same with the final prediction. It will be by majority vote, or let's say high score wins. And when to use each one. So one versus all, it's good for small number of classes, higher accuracy needed, and sufficient computational resources if you have a good resources. And also important is imbalanced dataset. If you have imbalanced dataset, you should use one versus one. And someone will see how to choose this. In the Python, if you are using Python, you can select, for instance, in both the packages from scikit-learn or any package, and there's a parameter to choose this the the foot. I mean, let's see the scenario, for instance, one versus all or one versus one. And one versus one, it's for a large number of classes. But here you can see in this one, sorry, in this one we have this number of classifiers, but here we have classifiers, n classifiers. So it's, for instance, if we have three classes, we will have three classifiers. Here we have three classes, indeed it will be three. But if you assume that we have 10 classes here, it will be 10 times 9. It will be 19 divided by 2. It will be 45 classifiers. But in this one here, if we have 10 classes, we will have 10 classifiers. So it's better for the large number of classes. And I think that's it for this one here. And I have been asked in this questions in several interviews, and also I asked the same questions when I was in the interview committee. Thanks for watching, and see you next time. So, machine learning models only learn what data shows them. If the data is noisy, biased, mislabeled, or unrepresentative of real use, the model will memorize shortcut of the field in the it will give you, let's see, rubbish data, rubbish result. So high quality, clean images or clean data, correct labels, balanced classes, diverse conditions like, for instance, in object detection, lighting, pose, and backgrounds, directly improves generalization, stability, and fairness, often more than extra model complexity. So it's not needed to use a complex model to get, let's say, fantastic results. So the data is the more important. It's the most, or let's say, the heart of the machine learning. So equally important is how we split the data into train, validation, and test set. A clean split give an honest estimate of the performance and also prevents data leakage. So in a computer vision or machine learning on any field, leakage is a common when near, let's say, duplicate frames or maybe a duplicated data. So in this video, we will try to see what are the scenarios of splitting the data into train, validation, and test set. I will go through this and we will see how some questions are coming. If you are expert, I mean, if you have, let's see, have experience and the position is high, for instance, or they have several experience, you will not be asked such questions. But just for the beginners, so what are the train and test? So the training test is the data that will be used to teach the model. And the model will extract, let's say, the patterns and relationship from this data. And finally, this model, we will test this model using another data, which is unseen data. So please remember this. You have test data, you have training data, and test data. The test data will not be seen, will not be seen, will not be see. Let's see, the model will not see the data, the test data during the training, and it's like studying for an exam with practical questions. This, let's see, consider as a training. And when you decide to not decide when you're taking the exam, real test, this is the testing. It will test, the teacher will test your let's see studying, or let's see the training, right? So this, we split the data into train and model. Now, why we need to split data into train and test data? So if I meet someone, let's say, great, let's say, at memorizing, but he can't solve any new problems. Sometimes you have, let's say, you can solve this specific problem, but if someone change it a little bit, adding some variables or maybe something like this, someone will not be able to, let's see, solve this issue. That's what happened when we don't split our data set into training and test. So if we test our model on the same data, so imagine that you are training your model with one data, right? And you test with the same data it learns from. It's like letting a student grade their own test. So they will get perfect every time, but they will haven't really learned. So splitting this data is trying to prevent, let's say, cheating, and also show if your model can handle new situations like predicting an apple price for varieties and it hasn't seen before. So training and testing on the same data is cheating. So you have to split data into tests. So tests act as unseen data to evaluate real performance, and will also help identify if model is truly learn patterns or just memorize it. So this is keep in mind. So testing on unseen data is a true measure of model usefulness. So how do we typically split the data? So standards is 80-20 training and testing, and or maybe 70-30. But the advanced way is to split your data into train, validation, and test. So this is the optimal way I would see to split it into training, validation, and test. This can be 70, 50, 50. And this question here, why we need a validation test and why it's used. So a validation test is a portion of data that can tune a model parameters during the development. If you are expert with, let's say, CNN and or maybe deep learning, and you have in the beginning we have forward propagation. Now, for the back propagation, we need to update the parameters. We update the parameters of the training model based on validation. If the model is, let's say, working better on the data, on the, let's see if the model is predicting the correct result on the validating set, it will be okay. If not, we will try to update or let's see tune the parameters. And also is compare model to select best performance. But let's say remember this validation set is like practice test before the final exam. So just keep it simple. So sometimes you're studying for this test and you have some, let's say, set of previous last year's exams, and you will try to prepare training study and test yourself before the final exam, let's say. And this validation set is really important for the deep learning. So what is the limitation of train, validation, and test? It's sometimes overfitting, underfitting, and also randomness. So sometimes you split the data into different results. So, so the important let's say note is that each set have to be are coming from the same distribution. For instance, if you are training on detecting cars, the validation and also test have to have, let's say, cars. If you have training on detecting bottles and the validation has no buttons, this will have overfitting and also maybe underfitting. So a better technique is to use cross validation. Is use multiple train test split for more reliable evaluation. If you would like to evaluate correctly your model, you have to use cross validation. And remember, finding the right balance between the simplicity and complexity is the key. I think that's it for today. And if you have any question, just drop it down in the comment below. I will definitely answer it. Thank you again. Training a deep learning models from scratch can be expensive. It takes, let's say, tons of data, huge compute resources, and also a lot of time. But what if your model could stand on the shoulder of other models? So that's where the transfer learning comes in. So here's how it's work step by step. So in the beginning, select the pre-trained model. For instance, ResNet, it's already trained on ImageNet, let's say. and start with the model that has already been trained on a large dataset like ImageNet, Coco dataset. This model already knows how to detect general features like edges, textures, and also shapes. And for instance, if you have an industrial dataset, and if you try to use ImageNet, the features might be not be, let's say, well detected. So in this case, I will show you next time how to do stuff. And the next step is to freeze layers. For instance, this is our model, and this is, for instance, these are the layers. I will try to freeze these layers here, freeze the weights. So these weights will be constant. It will not be updated. Let's see, it will be, for instance, uh, forward forward propagation, and the back propagation, it will only update this, for instance, layers here, and this won't be updated. And by freezing the earlier layers, you preserve the features that the model has already learned. And the third step is replace the output layer. So if the network, let's say, or the pre-trained model is used for classification of 1000, let's say, classes, and your dataset has only two class or three classes, you have to update the head, I mean the output. So now it's time to adapt the model to your specific problem. So replace the final output layer with one that match your, let's say, your data set. And as you said, for instance, classification. And oops, the fourth step is fine tune, which is adjust the weight using your new dataset. So this step is just refine the model, allowing to specialize for your task, while still, let's say, benefiting from the knowledge it started with. And for instance, when I try to train, just an example, YOLO, I will not train it from scratch. I will try to freeze some layers, let's see the earlier layers, and see how it's performing. If it's performing well, I will try to continue. Otherwise, I will try to, if I have a good data, I will train it from scratch. And what are the benefits of the transfer learning? It's reducing time training, less data required, and also improve the performance. And it's also using the existing knowledge. So this is the goal behind transfer learning. It could be asked about what is the transfer learning, why we need to use it, what is the advantage, and etc. That's it for today. And if you have any question, just drop it out in the comment below. Thanks for watching. Bye bye. In this section, we will try to focus on MLOps best practices. And for instance, in the interview, you might ask what what is the model registry and why it's important in MLOps. So a model registry is a centralized hub to store and version, stage, and track ML models. It ensures traceability, reproducibility, and safe deployment across team. And also, you might be asked, what is the best practice for model saving releases? So you can use staging, production overflow, automated CI/CD pipelines, model validation, monitoring to ensure only test models reach, let's say, production. Or maybe, let's say, they would ask, how do you handle rollback if a production model performs? So if you have, let's say, update your model and you figured out that this is not the right model, and how to roll back, let's see, to go to the previous model. And in this case, you can answer using the registry model registry, because model registry it saves the versions, the history of your models, and it's easy, let's see, or quickly refer to the previous stable models. So maybe you can ask what is the difference between model tracking and model registry in ML flow. So model tracking is track logs, experiments, parameters, matrices, and also artifacts. Let's say the models. But the registry here, it means manage deployment models, deployed models, their, let's say, phases, stages, life transitions, for instance, stages, production, and archived. So that's it, I think. And if you have any question, just drop it down in the comment below. Thanks for watching. Previous video, I have covered the most important questions in the traditional machine learning. Now we will try to dive into the convolutional, or let's say deep learning. And I will try, because I'm focusing on computer vision stuff, and I will try to start with convolution. So say will ask you, for instance, what is the convolution? What is the difference between CNN, convolutional neural network, and fully connected layers? And as you can see in this example here, in this figure here, the convolutions are like trainable features magnifiers. And as you can see here, this is, for instance, the kernel, let's say, or the weight. In the fully connected layers, each pixel has to be connected to the next, let's say, for instance, each pixel has to be connected to the next, all of the neuron. But in this here, they only focus on local patterns, and like edges, texture, and a small, only a small region. And as you can see here, the most advantage of CNN, or convolutional neural network, is that they are using the weight sharing. And you can see here, this weight is the same for all the images. And you can see here, this is, for instance, the first region, and the next region, so for instance, it will be, if we assume this, it will be like this one here. If we add +1, let's say column 1, and it will be the same weight for all of these regions. And here's this, for instance, how to calculate the pixel, the main pixel here. For instance, the center pixel will be, it should be here indeed, but this is wrong indeed. And as you can see here, this is only multiplying -1 times 3 plus 0 times 0, this one 0 times 0, plus 1 times 1, plus -2 times 2, plus 0 times 6, and etc. And the sum up all of these operations, it will be -3. So we can see this pixel here will be -3. And as you can see here, they are, let's see, scalable, and handling images of different sizes, and also translation invariant. So if you see here, if you have a big image, let's see, 1000 by 1000, you will have small patterns. You will have small, let's see, filter, and you need to have a big, let's say, connections, like in a convolution neural network. And you can see here, it's local patterns. It's extracting local patterns in this region here, weighting shear, and efficiency. So it's a few number of parameters, uh, like let's say, compared to fully connected layers. And I have also upload a video. I will put it in the description, or maybe it will be up here, on the how to calculate the convolution in more details. And you can see scalability. You have already seen if it handle any different size of images, and also transition, if the detected features regardless of the position. If this region is here, or might be here, it will be the same, let's say, number of features. I think that's it for today, and thanks for watching, and see you next time. Why we need to normalize or standardize the features? So do you know that your model might be unfairly, let's say, focusing on some features, just like because they have bigger numbers. So scale features because some algorithms need the features has to be scaled, or let's say normalized, like support vector machine in, because they are distance based, and they will think that each in years, for instance from 0 to 100, is more important than the income in 20 to 100,000. So this is, let's see, the why we need to fit the scaling the features, and there are, let's see, two different steps, or let's see methods: normalize and standardize. And normalizing is scaling the data to a fixed range, usually between 0 and 1, minus 1 and minus 1 and 1. And you can see here's the minimum and this is the maximum. Just taking this minimum and maximum from the data set and normalize the data. And all the features or all values are squeezed into the chosen range, and the algorithm rely, when you want to use normalization, if the algorithm rely on distance measures, for instance KNN, key means, support vector machine, and for instance maybe neural network, deep neural network, you can use normalization to make the gradient descent really fast. And for the standardization is to transform the data with to have zero mean and standardize standard deviation 1 unit. So after, let's say for instance, if you have a data set and you calculate the mean and the standard deviation with the standardization, and the result, if you calculate the mean, it will be 0 and the standard deviation will be 1. That's why it's called zero mean and standard deviation unit, or 1. So when to use standardization? Standardization is that assume the data is normally distributed. So if you use linear regression, logistic regression, principal component analysis, and uh, and in general, these feature scaling is used if you have a different feature scaling, distance based algorithm, gradient descent, and regularization. We will see how the regularization is working. And the benefit is, you can see, instead of calculating the distance, for instance, with the big numbers, and it will be faster convergence, improved accuracy, equal feature influence, and better optimization. I think that's it for today. If you have any question, just drop it down in the comment below. Thanks for watching. So are what are, let's see, the IO and MAP? So when you try to detect, let's see, this is an object detection, for instance, and when you see my object detection, let's see, model or algorithm is working well. So this you have to these measures. So the IOO, so it's stand for the uh, intersection over union. So you can see intersection over union, and it measures how much the predicted box overlap with the ground truth box. So you have the detection, you have the detection, for instance, bounding box, and you have the ground truth bounding box. And if you just see the how much overlap, how much these detections and the ground truth is overlap. So if there is no overlap, so you can see, for instance, here it's a big good overlap, and this is the union. If there is no overlap, the IAU will be 0. If it's a perfect match, it will be 1. For instance, this will be, for instance, perfect match. And it's calculated as the area of overlap divided by the area of union. And usually an IAU above zero point 0.5 is considered as correct detection. So if the overlap is greater than zero point 0.5, it's considered as a good detection. And now let's move to MAP, which is mean average precision. So this one measures the overall accuracy of your detection model across all classes and IO thresholds. So it's based on the precision recall curve, gives us a single score that tells how well the detector performs. So for instance, M let's see, of course you have seen it several times, MAP at zero point 0.5. So means you are using the an IO, let's see, intersection of over union threshold of zero point 0.5. So you will have to use, for instance, different thresholds. For instance, if it's zero point 0.5, this one is zero point 0.5, zero point 0.9, zero point 0.8, and you will have to calculate the average of these. So intersection over union tells us how much overlap between prediction and the ground truth, and MAP mean sorry, mean average precision is telling how accurate your, let's say, detector is overall. And sorry, and let's say IOU tells how will each pixels, let's see, each box fit, and MAP tells how will the entire model performed. And yeah, if you have any questions, just drop it down in the comment below. Thanks for watching and see you next time. Understanding this concept, loss function and metrics will make you confident in your interviews. So in today's video, we'll see what is the loss function and what is the metrics and what is the difference between these two concepts and when to use these. So imagine that you are planning, let's say you are playing basketball, and the loss function is like your friend is standing behind you, or maybe your trainer, and tell you a bit to the right, a bit to the left, or maybe higher, and until it's perfect. So it is the feedback that helps you adjust your shot. So the matrix is what you tell your, let's say, trainer later. I made 7 of 10 shots. That's the score that you have done. So as you can see, the let me just go here, and the loss function are for machine, but the matrices are for the human. So what are the differences between loss and metrics? So as you can see here, loss function used during the training to optimize the model. Assume that you are training the model, and after the forward propagation, you will calculate the loss function, and let's say that the mistake, or let's say the mistake or error, and you would like to update the weight for the back propagation. So the loss is used during the to optimize the model, and must be differentiable for the gradient descent, and directly influence model parameters. So it's based on the loss, we will update the parameters, and some of these are MS mean square error, cross entropy, and Hooper loss. And for the matrix, it's used for after the training to evaluate the performance. It's not need to be differentiable, and it has to be, let's say, human interpretable. For instance, accuracy, precision, recall, F1 and F1 score. Okay, so now when we should use loss or metrics, as we have already said, it's used for the training, optimize the parameters, calculating the gradient, improving model interacting. For the metrics, it's used evaluating the performance, communicating result to the stakeholders. For instance, after let's see testing your model, you have to, let's see, write the results to the stakeholders. that has to be, let's say, understandable for the stakeholders, and compare with different models. Make business decision. If for instance accuracy, for instance, if detecting the defects, if it's uh, more than 90%, or let's say 99%, it has to be defected. So the system will take a decision that this let's say package or this item will be destroyed. And as you can see here, this is the loss is starting high, and with time it's getting closer to the zero. Let's see, to the zero. But for the accuracy, it's for starting zero, I mean close to zero, and improved over time. So this is the difference, let's say, between loss and accuracy in terms of the training. And you can summarize, let's say, we can summarize the difference, the comparison between this. It's optimize the model. I mean, here evaluating the model and etc. So usage is training, and here it's used for the evaluation. So as you can see, loss is decreased during the training, but the accuracy might be increased. And as you can see, for instance, this loss optimize the model, but metrics communicate the result with the stakeholders. I think that's it for today. And if you have any question, just throw it down in the comment below. Thanks for watching, and see you next time.
Also, you might be asked, what is the main difference between CI/CD for ML and classic ML, let's say, CI/CD, or let's say classic software. So classic CI/CD focuses on code testing, integration, and while the ML or machine learning CI/CD is to also to handle data models and matrices to ensure the consist performance. And also, they would ask, why can't we use the normal DevOps pipeline for machine learning? So because ML projects depends on data model and model behavior. So it's not just code. So we need extra steps for data validation, model retraining, and performance, let's see, tracking. And the third question might be, what are the key components of machine learning CI/CD? So here you can see they include data validation, model performance evaluation, and reproducibility checks. In addition, let's say to usual code versioning and testing. And also maybe the question might be, how do you ensure reproducibility in machine learning pipelines? So you could say by versioning data, code, and models together, and tracking experiments parameter using tools like we have already discussed in the previous video, ML flow, or maybe DVC. So I think that may be the most, let's see, important questions. Yeah, thanks for watching. And of course, if you have any questions, just drop it down in the comment below. Thanks for watching, and see you next time. Here we will cover the most, let's see, important questions in DevOps topic: blue, green versus, let's see, canary releases. What are they, and what are the differences, when to use, and let's see, what is the blue green deployment? So the blue green deployment, I have also discussed this in the previous, let's see, playlist of the MLOps. So it's a strategy with two identical environment. Blue is live and green is the new version. So you deploy to green, test it, then instantly switch traffic from blue to green. Let's just assume that e-commerce website is upgrading, let's see, checkout flow, and it tests the new version on green and flips traffic instantly. If something breaks, they can switch back to the blue, which is, let's just give it in another way. So you have developed a system, and the first version is already running by the customer, which is called blue. And now you have added another, let's see, features. So before, let's see, pushing, let's see, or let's see, give the customer the green, uh, the new version. So you would like to test if this the new changes, the new deployment development is working perfectly. So now you can see use it's called green. It's just give it to split, let's see, the performance between blue and green, and you can see now if the new version has any issues, you can easily go to the blue without any issue. And the benefit of what is the benefit of blue green? It's zero downtime, so you didn't need to shut down this. Let's see, to shut down the system and give the new system. And also an instance switch. If you have any found any issue in the green version, you can directly go to the blue. And also easy rollback. So because if green is not working, you can just deploy blue. And now, when should you use the blue green? So when you need fast, risk-free releases, like banking on or healthcare systems. And the the releases. What are the canary release? It's a gradual roll out, release to a small user slice, monitor, then expand. It's like when you see, I think you see some features maybe in a on WhatsApp. You have, let's see, a new features while your friends or your wife or some your relatives have these features. They have no these they haven't these features. So this is called canary. So they try to release this version, the first let's see, just give the new version to small number of users, and if it's working correctly, they will increase. Let's say they start with 5%, and if everything is fine, they will increase this to 10%, to 20%, 30%, and after a while, they will release the new version to all the users. So what are the advantage is low risk, because you just split it into 5% for instance in the beginning, and also it's real user testing and easy performance monitoring. And what is the downtime? What is the side down? So it's a slower rollout and more complex traffic management. So imagine if you have rolled to, let's see, 50%, and you need to go now to the old version. So it's complex and you need traffic management. So as I said, the example, it's like streaming app releases. So when to use this canary? It's when you want safe data-driven testing in the production itself. So this is the production. So the green blue is instance switch between environment. Canary is gradual rollout to a small traffic slice. And I think can we, let's see, use both canary green, I mean blue green and canary, let's say combine them. So you can, yes, you can deploy to green, then gradually shift traffic to let's see, to the new version. And yes, that's it. And if you have any question, just drop it down in the comment below. Thanks for watching.